Hello everybody, this is Amel, and today I'm going to show you how to solve the permutations problem. Given a collection of distinct integers, return all possible permutations. Example, as an input they give you an array with the values 1, 2, 3. So the output is a list of integer. So it has all the permutations. So as you know, a permutation is a rearrangement of elements. So all the possible ways to rearrange the elements in this array. So as you can see, 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, and so on. So how can we solve this problem? Well, we can solve this problem recursively. So we have to think recursively. We should find a pattern in the permutations, and then from that pattern we can think recursively and find a solution. So if you notice, you can say that these permutations here start with 1, and these two permutations start with 2, and this with 3. So you can define this recursively by saying, okay, I'm gonna choose an element, the first element 1, and then the other elements are gonna be permuted. So you can say 1 plus permutation of 2 and 3, and that's gonna give me 1, 2, 3, 1, 3, 2. Then after I'm done with this element 1 at the beginning, I go back and now I choose the next element 2, and then I'm gonna say, okay, the other two permutations are gonna be 2 at the beginning plus the permutation of 1 and 3. So that's gonna give me 2, 1, 3, 2, 3, 1. Then I go back, and then I go to the next element, which is 3. So I say, okay, and the last two permutations are gonna be the 3 at the beginning plus the permutations of 1 and 2. So that's gonna give me 3, 1, 2 and 3, 2, 1. And that's the recursive definition. As you know, solving a problem recursively involves solving smaller problems in a self-similar manner. So that's how we solve it. We say this element plus the permutation of the other elements. And we also have to think about the base case. The base case is when the recursion is going to stop. So we're going to traverse the array, and as we traverse it, we're going to recurse, and as we are recursing, we are going to have a list. Initially it's going to be empty, and that's going to be for one single permutation. Whenever the size of the list is equal to the length of the array, then I know that I have one permutation, and I can add that permutation to the final result. And that's going to be the base case, when the size of the list is the same as the size of the array. So without further ado, I'm going to show you how to write the code. Also don't forget that the time complexity of this solution is going to be big O n factorial, because we have to generate n factorial permutations, because an array that has n elements has n factorial permutations. So without further ado, I'm going to show you how to write the code. First, I'm going to have a list of integer result. That's the value of new array list of integer. Then I'm gonna check the nums array. If it is null or nums.length equals 0, return an empty list as the final result. Because if the reference is null or there is no elements in the nums array, there are no elements in the nums array, then return the final result as an empty list. At the end, return the final result. So I'm gonna have to have an array of booleans. I'm gonna call it used. Gets the value of new boolean array of size nums.length. So what am I gonna use this array for? So I'm gonna use this to mark the element that I'm using at the moment. So as you see here, first I'm gonna use the number 1. So I'm gonna say 1 plus permutations of 2 and 3. So when I use number 1, I have to mark that using this array of boolean. So I'm gonna say that the 1 is being used, so I don't have to use it anymore in this recursive call. So when I go back, when I'm done processing the 1 at the beginning, then I move to the next element, so I have to unmark it. So I'm gonna set the value to false. So you will see in the recursive call when I'm doing that. I'm gonna need a list of integer that's gonna be permutation, because the value of new array list of integer, and this is gonna be the one that is initially empty, and as I traverse and as I recurse, I'm gonna build the permutation, and I'm gonna check if the size is equal to the size of the array. Then I have one permutation, and I add a copy of this list to the final result. And then I'm gonna have my recursive method. I'm gonna call a helper, because it's gonna be a helper method. I'm gonna pass up as a parameter nums the permutation used and the final result. Okay, so down here the helper method is gonna be private. It's not gonna return anything. It's gonna take as a parameter an array of integer nums, a list of integer permutation, an array of boolean used, and a list of integer, the final result. So now I want to take care of the base case. I want to make sure that I handle the base case. As I said, I'm going to recurse. Every time I'm going to add an element to the permutation, and whenever the permutation, the size of the permutation is the same as the size of the array, that's going to be my base case. So if permutation dot size equals nums dot length, then this is the base case. I have one new permutation, and I'm gonna add the permutation to the final result. Result that add permutation. So here you have to be careful, because this is a reference. So I don't want to add a shallow copy. I want to do a deep copy, because this list is gonna continue to be modified. It's gonna be modified when I go back. So I want to do a deep copy. New, so that would be new array list, and in the constructor I pass the permutation, and that's gonna make a deep copy. So it's gonna copy all the objects. It's gonna make a new object, and then I have to return back up, because I wanna go back, and then for let's say I'm finished with this number here. So when I return here, I will go to this number, and I will forget about this number. So it's gonna be 2 plus permutations of 1 and 3. So that's why I have to return back up. So as I said before, I have to go from left to right for integer I, because value 0, I is less than nums dot length plus I. Okay, so I go from left to right, and I'm gonna choose one number and say this number plus permutation of the other number. So how do I know that I have chosen a number? That's why I have a boolean array. So I'm gonna say if used sub I, then continue. So that means that if that's the number that I chose before, then don't do anything with this number, because this number has already been added. And then I'm gonna do used sub I, because the value of true. So this number have to be used now, so I'm gonna mark it. I'm gonna add it to the permutation that add nums sub I, and then I need to say, okay, so this number plus the permutation of the other numbers, that's when I do the recursion. So I'm gonna have to call the helper method, passing nums, the permutation used, and the final result. Okay. Then that's gonna do the recursion of the other elements. So when I come back, I have to unmark this number and also remove it from the list. Permutation that remove permutation that size -1. So I have to remove it from the list because the order of this element is going to change. So I have to remove it, and now I have to say used by gets a value of false. And now the one that is going to be used is going to be number 2 the first time. So it's going to be 2 plus permutation of 1 and 3. And that's going to give you 2, 1, 3 and 2, 3, 1, as you can see here. So this should be working. Let me run the code. Okay, it seems to be working fine. I'm gonna submit the solution. Perfect, this is working perfectly. So the time complexity is big O n factorial. That's the best you can do. There are other ways to write this solution, but this is an intuitive way to do it. So please like the video, don't forget to subscribe, and see you next time.